Data communication and networking, alias network and security. Hello all, welcome to my channel. After about 15 years of experience in networking and Wi-Fi industry, I have realized that there is a big gap between the practical world and the theoretical world. I am trying to bridge this gap by giving you live examples and real life problems. Overview of the network, agenda, data communication, the components of it, data flow, network characteristics, network performance, topology, and network categories. What is data communication? Data communication is nothing but transfer of some useful messages from one device to another. For this to happen, both the device must be within a communication system. What is a communication system? All the hardwares and softwares that are required to transfer the data from one device to another device. Example of communication system: satellite communication system, where a satellite is used to transfer data from one device to another. Example is DTH, the direct to home which we use for the TV connection. So this uses a satellite link system. Another example of communication system, telecommunication system, the mobile phones. The mobile phones which we use base stations. There are big towers to transfer the call from your phone to another phone. Okay. Next is computer networks, where a group of computers or nodes are connected with each other to transfer data. So we will be looking in detail about this communication system, right? Computer networks. Okay, so what are the characteristics of the communication system? Delivery. So when I transfer data to a node, it should reach only to that node. So if I transfer the data to a printer, it should reach only to that printer and not to any other device. Accuracy. It should accurately reach the device, so there should not be any tampering of the data, or the data should not get corrupted in the air because of noise. That is accuracy. Timeliness. Timeliness means how much delay is there. So when I send a data from timeliness. So when I send a data from one node to another, there will be some kind of a delay. So this is called timeliness. On the receiver side, we will reconstruct the message and give it to the user. Okay, so if the delay is more, we will have a bad user experience. Like when you start having a video call or a voice call, you will have to wait for the other person to speak before you can listen. So there will be a big gap between the speech and the time it takes to reach the message, right? So the user experience will be very poor if the delay is poor, but at least the delay is consistent, so the reconstruction will be easy. Jitter. Jitter is very dangerous, more dangerous than timeliness, because the delay between the packets are inconsistent, right? So the receiver find it very difficult to reconstruct the message. Okay. So in Wi-Fi, which is in the air, what happens is the packets actually even reach out of order. That is, the third packet can come here, the second packet can come here, and the first packet can come here. Okay, and reconstructing this will be very tough. Okay, so there are problems like this. That is because the packets don't actually go in a single line, they bounce off different objects and then reach. So depending upon the environment, right, this first packet might reach more earlier than the second packet. Over here the delay is consistent. The receiver gets one packet, it waits for some time, it gets another packet. Now it knows that if I wait for some more time, I will get the third packet, and so on. So it waits for some time, gets all the packets, it can pack it and send it to you, right? But over here it doesn't know how much time to wait for the next packet. Sometimes the packet is out of order. It is very difficult to reconstruct such a packet, such a delivery. Okay, so jitter disturbs the quality of the picture. So you see like this, it starts shaking. The voice would shake or the picture would shake because the reconstruction on the receiver side is very tough. That is jitter. Right? Components of data communication. Right? What are the components of data communication? The first one is the message, the sender, the receiver, transmission medium, and protocol. So you have one device here, sender, you have the receiver. What kind of medium they use to send the message from one device to another? It can be wired, right? It can be wireless, it can be optical fibers, Ethernet cables, right? So on. And there's a message here. And then protocol. So this is very important. We'll go deeper in what protocol means. Right? Protocol is set of rules given to the sender and the receiver and all the intermediate devices for transfer of message from one device to another. Let's take an example of Wi-Fi. So who writes these protocols? Mostly IEEE would write them. Let's take an example of Wi-Fi. So Wi-Fi protocol, it is written by IEEE, right? And there are different types of Wi-Fi protocol. One example is 802.11n. So you get 11n, 11ac, 11ax, so on, right? So there are different kind of protocol. You can download these from their IEEE website. So these documents will mention what is the TX power to use, what bandwidth to use, what is the data rate to use, right? What should happen during the handshake, what kind of security to use. Everything will be mentioned inside these documents, right? And Wi-Fi has to follow this protocol. So the Wi-Fi designers, or let's say Wi-Fi manufacturers read these protocols and write a program, and this program they will put it inside the Wi-Fi chipset. This is a Wi-Fi chipset, and they would have written the program over here, and they have many antennas, right? So once you want to connect your client to an AP, let's say this is the AP and this is your phone, right? So as soon as you switch on the phone and switch on your Wi-Fi in the phone, this program starts running and it tells the phone to scan certain frequencies, 2.4 gigahertz for Wi-Fi, right? All these are mentioned in the protocol. So it will scan this frequency and find out if there is any AP present. If there is an AP present, it goes for the handshake and they are connected. What kind of message to be exchanged? that is also defined in the protocol. Okay, so now they are connected in Wi-Fi protocol and they can start exchanging data based on the Wi-Fi protocol. All of these would be mentioned in these documents. Okay, so this is one example of protocol, right? So let us see a practical example of how a Wi-Fi protocol is followed and connected, right? Yeah, so as soon as you switch on your phone starts scanning the air for any APs. So it sends the probe request and AP sends the probe response, right? So once they know that they are there, I mean, it finds the AP knows there is client. The client said, I want to authenticate with you, and he says, okay, you can authenticate. Then there is association request packet. It will tell what and all it is capable of. Is it 11 and 11 AC or 11X? I can support this bandwidth, so on. And AP says, okay, you can join to me, and I support all of these. And then this is the security exchange. Once you enter the password, they exchange these 4 messages to verify that the password is correct, and then they join, right? And then they join and they transfer data. So all of these are mentioned in the protocol. What kind of exchanges should happen, where it should happen, what power, what rate, so on. So this is the channel number 6, which is the Wi-Fi frequency, right? Data flow we can divide it into 3 parts: simplex, full duplex, half duplex. Simplex means only one way of communication between the sender and receiver, okay, like your monitor or keyboard, right? From your PC it goes to the monitor, that's it. Monitor doesn't say anything back to you. Full duplex, the sender and receiver can talk to each other at the same time. This is your phone. You can also speak at the same time, the other person also can speak. So this is a full duplex. Half duplex is both can speak to each other but one at a time. So Wi-Fi, Ethernet, they're all half duplex. So if I am speaking, the other person have to listen. Once they finish and they will speak, then I have to listen. So Wi-Fi and Ethernet follow this. Network characteristics. So what is a network? Interconnection of nodes. So all of these nodes are connected to each other and they can talk to each other to form a network, right? So what is a node? Node can be any entity. So what is a node? Node can be any device that is connected, like your fridge, your phone, your printer, your washing machine, your geyser. So nowadays in IoT, all of these devices are able to connect to the internet, right? They are all able to connect to your Wi-Fi router. So everybody of those nodes who are connected to each other to exchange information is called a network. Okay, how do you characterize a network? Is based on its performance, reliability, and security. Let us understand each. Performance is based on transmit time, the response time, and throughput. Transmit time, the amount of time the device takes to send its data to another device. So this one depends upon the bandwidth, okay, and so higher the bandwidth, so it will be able to transmit more amount of data in this channel and it will take lesser time, it will take a quicker time. That is a transmit time. Response time is the collection of the whole network speed. So response time is once you ask a query, right? You ask a query and it goes through multiple routes, reaches your server, and the server reads your query, understands your query, takes the response and sends it back. So this whole thing from starting to the sending is the response time. And response time not only depends on transmit time, it has to depend upon how many intermediate nodes are there to pass the question, and how the server responds, how fast the server is, and how fast the server sends the response, and everything altogether constitute a response time. Right, the whole response time is the health of the network. Now the transmit time and response time both depend on the throughput is very basic. So you must have done an internet speed test, right, Ookla speed test, where they mention 116 or 120 mbps megabits per second. That means 116 bits have come to your phone after you have queried. So once you start the speed test queries, okay, it sends and give me so much of data in 1 second. So the server, it would send some amount of bits to you, and how much of bits you are able to receive in 1 second is what is written here in throughput. So that means you have a good network if around 100 mbps is there. So that means your transmit time, response time, all are very good, and your network speed is very good. Reliability. How do you say a network is reliable? Based on frequency of failure. So how frequent your network goes down, it should be very less frequent. And recovery, even if it goes down, you should be able to recover it quickly. So for in our examples, if a link goes down, we immediately get a message that there is a link down, and we can go and fix it, right? And robustness, so even if the link is gone, the worst case scenario, we should still be able to reach. So if you want to send the data from this PC to this PC, and let's say this link is down, so I should be able to send it using an alternate route, right? And if this route is gone, right, I should be able to send it through this way. Okay, so somehow or the other I must reach my destination. I must have at least one alternate route. So that makes the network robust. Security. Security means you need to protect your network from unauthorized access. So a third person should not come and join your network and enjoy your Wi-Fi for free. So that is in your home scenario. But in case of office scenario, where corporate office have data with sensitive information, any third person into their network and accessing their sensitive information is a very big security lapse. It can cause a lot of damage to the organization. Okay, and protect from damage. The data you send, right, the hacker, what he can do, he can sniff it, take the data, he will change a few parameters and send it back like it has been sent by you. So the server would think, oh, okay, he's the one sending, so he will reply, and he would sniff this packet also. For example, you say send me 500 rupees for account ABC. The hacker would take your packet, he will say send me $5,000 for account BCD, and he can send it back. The server wouldn't know that it is an hacker. It will think, okay, you want to send 5,000 rupees, right? And he will send the 5,000. So this is the damaging your packet, changing the information and sending it back into the network. Right? Data loss. What the hacker can do, he can send you messages saying that you're no longer connected to the network. So you will try to connect again. So when you're trying to connect again, he will try to hack your password and username, right? And he can keep sending you these messages that you're no longer connected, so that your data does not go through. So now that is a data loss. We call it denial of service. Okay, so these are all security issues, and Wi-Fi is very vulnerable for these securities because it is all in the air. Anybody can come, anybody can sniff. So security is a big concern for Wi-Fi, and there are a lot of security protocols to make it as secure as possible. Network topology. So these are the different kind of topologies. One is point to point, from point A to point B, direct connection. And bus. there is a backbone network here, backbone hall we call it, backbone wire. From there the different PCs tap in and to get the data. So it is easily scalable, so you can just keep adding your PCs here and you will be able to receive the data. The problem here is as you keep traveling, the power keeps reducing, so he gets very less data, so there is no repeater or anything over here, right? So that's a problem over here, and nowadays it's not very much widely used. They're all being replaced by Ethernet, right? And ring topology means the data travels in one direction, everyone gets a chance to speak in the circular order. So if you want to send from A to B, you cannot just send like this, you'll have to send the message and they will relay it to you one by one, right? And each one can increase the power of your message, enhance, they repeat, right? So the power is not lost, so it will be a very strong signal from A to B. Okay, but the problem is if one link is down, you are broken. You will have to you can reverse the order, but still you will not be able to reach this guy, right? So it is a problem, and the time it takes is also very high. So from A to B it is shorter to go like this, instead you'll have to go around like this. So think if there are more number of PCs, the time to reach even your next neighbor is going to be very high. Okay, so these are used in some industrial applications where you'll have to monitor the PC's health very critically. So if one link is down, you have to know it immediately. So they check every PC's health in a circular fashion, and if something is down, you immediately get to know. So that is the application of a ring. Star is what we basically use for deployment, Ethernet deployment in your networks like college network or office network, home network. So you have a central switch from where all the devices are connected. And nowadays these switches are very smart, so if you want to send from A to B, the hub will tell which route to take and he will take you there. So there's no need of any other devices in between to read your data. Okay, it is direct, straightforward, and hub decides which port to take to. So he knows port, this device B is connected to port here, so if I see a data to B, he will forward it through this port and he will get the data. Okay, so this is the most widely used. One problem is if this hub goes down, your whole network goes down. Okay, so that is why we have to design it very reliably. And tree is nothing but collection of stars. Okay, this is a one star network, each of them is a star network and they are all interconnected. So tree and leaf topology is what we use for big deployments like campus deployments. Okay, and mesh is interconnection of the devices. So each device here is connected separately to each other, so he has a full dedicated link, to him, right? And he has dedicated links to each and every device here. Even if one link goes down, he can speak to everybody else and he has a full bandwidth, nobody is interrupting him, no collision, nothing. So this is very stable, very robust, but only issues, the number of wires here is too much, number of connection is too much, it's very hard to maintain. That is, so mesh is used in high sensitive military operations or any emergency condition like hospitals and other things. And one more common example of mesh is the Wi-Fi mesh which you use at home. So let's say your home is very big, right, and you have first floor and second floor, so on. So what you do, you keep one Wi-Fi router here which is connected to internet, and then you keep one more Wi-Fi router over here which acts as a mesh, right? So they both speak to each other. So all your phone, TV which is connected over here, it goes to this Wi-Fi AP and then it connects to him, then goes to the network outside, right? So similarly you will be having and another Wi-Fi router here. So we have another flow, you have another Wi-Fi access point here. So all these access points kind of form a mesh. Okay, so this is the Wi-Fi mesh to enhance the Wi-Fi experience. And hybrid network, hybrid means mixture of these topologies. So the most common example is the star and bus mixing, where you have a star over here and then the bus over here. So nowadays the bus now comes with optical fibers, and the devices can just drop in and extract the data, and this star makes sure that each of these buses can speak to each other. Network categories. What are the different network categories? LAN, WAN and MAN. LAN means your local area network. So these are all devices which are connected, let's say within your home, within a small geographical area. So you have let's say wireless access point here. So all your devices from printer, TV, fridge, camera, all are connected to a LAN, and they can speak to each other without an internet. So even if your internet goes down, you should be able to ping from your laptop to your printer, laptop to another PC. So they can just speak with each other. Okay. And WAN is the wide area network. So if you want internet, if you want a google.com, or you want to go outside of your home, that's where WAN comes in. So WAN, your service provider, right? You have Act or Ticona, whoever is your service provider, you pay your internet bill to them, right? So what do? They take your data, and they have a big router, right? And they route it, they find out where do you want to go, and they take you across the continent, because a Google server could be in Asia, could be in US, wherever. So they go across the continent, across the countries, and then they take you to the server, and the server sees your query and replies back, and they bring it back to you. So this is across the world, anywhere in the world you can reach because of WAN. Okay, and this is being provided by your ISP, internet service provider, who takes your data, routes it across. There will be fiber optic cable under the ocean. Your data might go through these fiber optic cable under the ocean and then reach to the other side of the country, right? And MAN is similar to LAN, but it's a little wider space. So suppose you have multiple buildings in your campus, right? And there is local LAN inside. So what you can do, you can connect these buildings using a MAN. So there could be a fiber optic running across these buildings, and whatever traffic is there, you can share among them. So this is not open to the outside world. Nobody from outside world can come and access your MAN. So it is your local connection, but within a wide area. So that is MAN. Thank you. Stay tuned for next chapter.